Hello everyone. In this video we're going to be doing Valid Palindrome 2, which is LeetCode problem 680. So this states, given a string s, return true if the s can be a palindrome after deleting at most one character from it. So a little bit of a wrench on the initial palindrome character. So ABA is true, that's a palindrome. ABCA is also a palindrome because we can remove the C. And then ABC is false because removing one character doesn't make it a palindrome. Alright, so let's see how to do this. So we're going to use recursion on this one. And what we're going to do is we're going to start with the method they give us, passing back a Boolean for true or false, and passing in the string. So this is where the recursion comes in. This is the recursion method. We're going to return is palindrome. We're going to pass in the string. We're going to pass in 0 for the left value. We're going to pass in s.length minus 1 for the right value, and then this is basically our one strike that we get to remove a letter. And we'll start, that will be false to begin with. So let's diagram out that, or let's draw out that method. So is palindrome, like I said, has the string s, has a left, a right. So we're going to have a left pointer and a right pointer. And we're going to do just like we did with the original palindrome. We're going to compare the leftmost character with the rightmost character, and then move the left to move it inward, and then move the right inward as well. So we're actually going to move the left value right and the right value left, if that makes any sense. And we have a Boolean is character deleted. So while left is less than right, we don't want the pointers to overlap. So if the character at left is not equal to the character at the right, so then we got to do some stuff. So first we need to check if we've had that mulligan or that strike yet. So if character deleted is true, then we're going to return false. Otherwise, we're going to return is palindrome. Now, this is where it gets kind of tricky. So we're going to pass in s for the string, and then left plus 1, and the right value, and then true for the character deleted. So we have our one pass, basically. Or we're going to call palindrome with the string and increment the right, or decrement the right value and pass in true. So what this is basically doing is, as we create instances of is palindrome, we're going to start by incrementing the left to see if that fixes it. And if it doesn't, we'll return false, which will kick us out of this instance, but we still have this instance. So we have the second, we got the second chance effort. So once we return false from this method, we can kick this method off and see if we can get a result out of that. And the debugger will show this. Well, I picked an example that actually has this type of situation in it. Okay, so that's that. Okay, and then otherwise, so if the character does equal, the left does equal the right, then we're just going to increase the left and decrement the right. So this is basically the normal palindrome method with this extra stuff in here for the one free pass that we get. And at the end, we're going to return true if we never get a false out of is palindrome. The final is palindrome, then we'll return true. And that is pretty much it. All right, let's debug this. I think that should clear. So I picked an example, ABCCBAB, where this will be a palindrome if we remove the final B there. So let's go through this. So we're passing in the string, left is 0, right is 6. Is character deleted is false. So we're going to go through this. So left is A, character at left is A, and character at the right is B. So character deleted is false. I'm going to leave that alone. So now we're going to call is palindrome. We're going to increment left by 1. and leave the right alone. So if you look here, we've got left is 1 and right is 6. Now they're both B in this case. So that is false because they're both the letter B. So now we're just going to decrement or increment the left and decrement the right. So now we have 2 and 5. So now we're comparing C to A. So now the character left is not equal to the character at the right. Character deleted is true, so return false. So what this is doing right now is we just ran this method or this instance where we increased the left value by 1. So now we're going to go into this OR condition where we're going to decrement right by 1. So if you look at is palindrome now, we're back to 0 with the left, but right is now 5. So we've decremented right by 5. So now we have A is equal to A. So left now becomes 1, right becomes 5. Or that was what they were. So now 1 is 4. So now all these, now we're comparing B to B. So then we're just going to increase left and decrease right. So now we're comparing the C to the C. And now we're going to get into the situation where the left is not less than the right. And that will return true. Where are we going? Yes, true. So that is in fact a palindrome by removing one character. All right, so let's run this through LeetCode and see what we get. That is successful with the ABA input string, and we're faster than 99.95% of submissions and use 76.2% less memory. All right, and as always, we'll go through the space and time complexity. So time complexity is O of n. We have an input parameter, and we're basically going through that. We're using recursion, so it's creating multiple instances, and that as you have a greater input parameter, you're going to have to create more instances. And the same for space. We're going to create more instances. We create instances of the initial string for the recursion, and so that's O of n. Same here. And that is it. So thank you again for watching. Let me know if you have questions, and we'll see you next time.